Welcome back once again to my channel. Today I have decided to find another way of presenting mathematics for all of us to comprehend it very well. And so I have quite different tools that we can use to teach the mathematics for your understanding on this particular channel. This is your math alarm. If this is your first time of hitting my channel, make sure you give me a subscribe and a like so that YouTube can promote my content very well. So today we'll be talking about plane geometry 2 with some worked examples. Plane geometry 2 with some worked examples. Now let's get into the video and go. We are taking the question 1, and the question 1 says that line AB, so line AB from the diagram is the diameter of a circle. So when we talk about the diameter, it is the line that divides the circle into two equal parts. So the angle CAB, the movement is where the middle number or the middle alphabet is where the angle is. So we have CAB. So CAB, this angle is 41 degrees. So it means this angle here is 41 degrees. Now calculate angle X and Y, this angle here, and give reasons for your answers. Now plane geometry is full of theorems. So as you give the theory, use the theory to get your answer. You may want to give a reason. Don't give the reason, it means you are losing some marks. And so let's get the answer and we are good. So from the question, this angle here is 41. Now you want to look for angle X. From the properties of circle theorems, we say that any line that subtends from the diameter to the circumference, so the circumference is the distance around the circle. So we are saying that any angle that is formed from the subtending of two lines from the diameter gives you 90 degrees. So let's see that. So we say that angles in a semicircle, another fantabulous reason. So we realize that the diameter divides the circle into two equal parts, and that is making it two semicircles. So any angle that will form in that semicircle, which is touching the circumference, any part, that angle becomes 90 degrees. So it means this angle here is what? 90 degrees. So we have found our X. Now we want to look for the angle Y. Now from the angles theorem, and that's plane geometry 1, we said that angles in a triangle sum up to 180 degrees. There is a video I've made under that. I will leave the description in there so that you can go and look for it. So we can sum this angle, and that angle. So this angle is ACB or BCA, and this angle here is ACB. That's this one. CBA is the Y, and then CAB is the 41. So we are finding this angle Y. That's CBA. Now let's look at it. The angle there is 49 degrees. How do we get that? We just make 90 plus 41, and that's going to give you 131. But we said that the whole thing should give you 180. So you subtract that result from 180 degrees, and you're going to get your answer. So pick 49 plus 41 plus 90. You are going to get 180 degrees. So if you get your answer here and you add all the three angles, and it does not give you 180 degrees, then you suspect your answer and you go and try it again. And the theorem, the formula we are using is taken from the triangles or angles in a triangle. Now we take the next example. So that angle there is 49 degrees. So let's take our next example that we are going to do. Example 2. Work out all the missing angles. So we are working out A, B, C, D, E. They're giving us only one angle. You can pause the video and then try it out by yourself if you can do it. So mathematics is all about working, and giving you more ability to reason. Okay, so we start and we go. We want to look at angle A. Angle A. Look here. From the properties of angles or triangles, we said that an isosceles triangle have its two sides equal. And if the two sides are equal, we have two base angles equal. So look at where A is. This OC is a radius and OB is also a radius. Once OC is a radius and OB is a radius, it means that these two lines are equal. Okay? And if these two lines are equal, it means the base angle must also be equal. Because this is a radius and this is also a radius. So it means that this angle here is equal to this angle. That's saying that A is 46 degrees. Taken from the isosceles triangle property. So A here is 46. Now we know 46, yes, it's 46. We can find B using angles in the triangle. Angles in the triangle sums up to 180 degrees. From the previous example, we have looked at that. Okay, so we sum 46 plus 46 plus B and equate to 180 degrees, and that gives us the angle B. Okay, so the angle B here is 88 degrees. Angles in the triangle sums up to 180 degrees. That is, when we take 180 degrees minus 46, the remainder is the B. We subtract this and subtract this, the remainder gives you B, which is 88 degrees. So when I sum 88 degrees plus 46 degrees plus 46 degrees, and I don't get 180 degrees, it means that your answer may be wrong, and you need to look at it. Now we have gotten B, and now with angle C. So we can apply the angles in a straight line to deal with that. Angles on a straight line. So we can see that the angle here, that is angles BOC or COB, is still referring to the angle here. And the angle COA or OAOC is the C. So this forms on a straight line, and we can sum it to say that it gives you 180 degrees. So angles on a straight line gives you 180 degrees. So you can get your protractor and measure it and realize that it lies exactly. The protractor is made of 180 degrees. So two of them joined together gives you 360. That's a complete circle. So when you measure here, you get 180 degrees, right? But here is 88. So if you want to get here, just take 88 from 180 degrees, and the remainder gives you this angle C. So we are looking for the C here. We said that the C is 92. Angles from the straight lines gives you 180 degrees. So we subtract the 88 degree from 180, then we get the angle C to be 92. Please, you can pause the video and replay it more if you want to get more understanding, and you can go to the comment section and put a comment there if you don't understand anything, and I will be happy to explain that to you. But please, if you like the video, leave me a like and subscribe. Alright, now level angle E and D. Angle E and D. Now notice the first one we looked at was angle A, and we use the isosceles triangle properties to look at that. You can see that OC is also a radius and OA is another radius, which means that triangle AOC is an isosceles triangle inside the circle. Now, when we talk about the circle theorem, it's just referring to angles that are inscribed in the circle. Okay? It's the same plane geometry one you have done, but here it's inscribed in circles. So that is just the only difference. And you have to apply some extra properties to it. So if this C is 92 degrees, the C is 92 degrees, then I can find these two angles because they are equal. This line here and this line are equal, so I can find the angle B. Okay. And we say that the angle B is 44 degrees. Angles in the semicircle is 90 degrees. angles in a semicircle is 90 degrees. Now we are using the property that this is a diameter, and any angle that is formed to the circumference from the diameter is 90 degrees. So it means that this is 90 degrees. Okay, this place is 90 degrees. So if here is 46, here will be what? 44 degrees. When you sum them up, you get the 90 degrees for here. The other way you can use it is we can add this plus this because they are equal. This and this plus this equal to 180 degrees. And if that is the case, we can take, if we are adding this, that will be 2 of that alphabet. And you subtract 180 degrees, you subtract 92 from 180 degrees and divide that result by 2, and you get the angles here. Okay? But the other property is one. So a school of properties, any of them you want to use, but when you use it, give a reason. Like I mentioned earlier, you can use a lot of properties, but when you give it, make sure the reason is very clear. Now, it means that angle D is 44. Now I know angle D. The properties that this angle here is equal to the angle here because it's an isosceles triangle. You can find E. Okay, this angle here, this line and this line are equal, so these angles are also equal. And then let's say that E is 44 degrees. Associate triangle property. So E here is 44 degrees. In other words, we could have also sum this plus E and equal to 180 degrees. And we can still find it. Angles in the triangle sums up to 180 degrees. Okay? So you can go through it again. Let's look at the next example. Okay. So you can see this line is the diameter over the multiple. The next example, example 3. Oh, this is a beautiful diagram, right? So it's saying that we work out angle X and Y and explain how you got your answers. O is the center of the circle and ABC is a cyclic quadrilateral. So cyclic quadrilateral. So the angle, the figure formed in the circle is a quadrilateral, 4-sided plane figure. So we have A, B, C, D. It's a quadrilateral because the 4-sided plane figure. And it is inside a circle. That is why the name is cyclic quadrilateral. Now, the center is O. The center of this circle is O. And we are looking for angle X and angle Y. We are going to use some of the theorems. In my previous video, I've stated the theories of these things. So I'm going to put the link in the description. You can equally go and look at it so that you're more comfortable with it. But just concentrate and you are good to go. So we want to look for angle Y, this angle here. Now there are various ways you can answer that particular one. And the first one we are looking at is that the angle here is half of the angle here. Angle here is half of this. So we can say that angle ADB, which is Y, is half of angle AOB. So if that is it, when you divide 130 by 2, you are going to get the angle Y. Angles at the circumference is half the angle at the center. That is the reason you give. Angle at the circumference is half the angle at the center. So just remember, this angle here is half of this. Alright? And this angle here is twice of this. So now that we know here to be 130, we divide it by 2, and we get Y. They are supposed to look for X and Y, so we can look for our X. So here is 65 degrees. Now let's look for angle X. Now, two opposite angles in a cyclic quadrilateral sums up to 180 degrees. So we can use that property. So it means that this angle plus this angle should give me 180 degrees. Okay? You are good to go. So when I take 65 plus 180 degrees, so plus X is equal to 180 degrees, and I take 65 from 180 degrees. What is left is 115. Opposite angles in a cyclic quadrilateral pass up to 180 degrees. That is the reason. So you must give it why you are saying that the answer is this. Okay, and there's another way you can do that. You must know the property that connects angle x here and this angle together. So when you know that you use angles in the circle, that's 360, and you find this angle. So 360 minus 130, you get this angle. That will be giving you 230. So when you know here to be 230, you can find here. So you realize that this also half of what is here, 230. So half of 230 gives you 115 degrees. So simple. Okay, so but use any of them if you want, but give the reason of the angle or how you have gotten your answer, because most of them you will not be solving. So they want to know how you got your answer. Alright, so it means that this angle here is 115 degrees. Remember, the degree is very important. If you don't put a degree, then you are not talking about the angle, and that will make you lose some marks. So make sure that the degree is always there. Now, we look at example 4. Calculate angles A and B and give reasons for your answers. You know, like I mentioned, reasons are always very important. So we are calculating for this A and B. We have been given this angle XOB. So just 140 degrees. We can get A. Okay, you can look for angle A. The previous one, we looked at the property that the angle at the circumference is half the angle in the center. So just look at the property. Angle at the circumference is half the angle here. So if here is 104 degrees, what will be here? This is half of this. So it means that you're going to divide this by 2 to get 52. 52 plus 52 will be 104 degrees. So it means that angle A is 52 degrees. And the reason is that angle at the edge is half the angle at the center. So the edge here is talking about the one that is subtended at the circumference. And that is going to give you 52 degrees. Now look at this angle here, this one. So any part that is subtending from here, you realize that it will also be the same. So here will also be half of this. But there's another theorem we're going to use. Okay? So we're going to look for angle B. Look for angle B. So angle B, the theorem says that this angle here is equal to the angle here. This angle here is equal to the angle. So it means that XWY, angle XWY is equal to angle XZY. Okay? And if here is 52, here is also be 52. And the first theorem we used to got this is divide this by 2 to get that. We say that the angle at the circumference or the edge is half of the angle at the center, which is the same as this. So those two properties you can use together. So it means that angle B is also what? 52 degrees. Okay? So same as above. The angles has just moved right the edge. So this one has just moved to this side. So that's why it's the same. Okay? So it means also at 52 degrees. Alright, thank you very much for watching, and please once again you can subscribe to see more and hit the notification bell so when I release any other new video you'll not be left out. The tools that I'm using now, I just told initially that I've bought some new equipment that helps me to do this. I bought a tripod stand and I have a microphone, which is this I'm now using, and so I will put the links on the description. So if you want to get them for yourself, you can just go to the description and click on the link. It will send you to Amazon to go and buy it. Okay, so the tools that I'm just using are just few. I'm not using a camera, I'm using my own phone. There is a lens, a camera lens that I am using, and I'll put that one in the description also. So it doesn't matter the phone you are using, you can use the lens to better your video. Thank you and have a nice day.